Okay, so I'm going to talk about how to write an app that lets you log in securely using an email and password set of credentials, which will help you kind of control who can and cannot access the app. So, for example, here we're logging in as Dale Gribble, and we've got a certain password. And when I type it correctly, it allows me to view a form where I can interact with the SQL database to select information from it, like what I'm doing here, viewing the users. So it's obviously got handling for invalid credentials. We're going to talk about how to do that. The first thing we need is to make sure that all of the prerequisites are installed. I'll leave this up on the screen for just a second. You can pause the video if you need it. We're going to need SQL Server 2019. I just use the developer edition because it's free. SQL Server Management Studio is also free. We need that to actually interact with the databases, create them, and so on. We need Visual Studio. I use 2019 Community, which is not really free, but you do get kind of a free trial. And when you install 2019, you got to be very careful because out of the box, it doesn't really give you everything you need. So you've got to select during the installation these options for these workloads that I've got listed here, which are going to enable us to build a WinForms app, which is just kind of a desktop application. And make sure, of course, after you install all that, you want to reboot or you're going to have a hard time connecting to the apps, running what you need, whatever. All right, so let's get started. So to start from scratch, we'll just start with the back end here. I've got a database installed on my local machine. I'm just running SQL Server on my desktop. TestDB01, that's where all this stuff lives. We'll go ahead and build it from scratch, though. We'll kind of assume we're starting from nothing. The very first thing I always like to do is make sure when we're connected to the database, doesn't matter who we're logged in as long as we are a system admin. So I'm connected here as like a Windows user. The login we're going to need is going to function as sort of a service account. This is always a really good idea when you're working with applications to have a dedicated SQL login that the app uses. It helps you troubleshoot better. You know that any queries being run by a certain user are definitely coming from the app. It's also good for security reasons. The whole point of an app usually is, we don't have to give SQL access to the people who are interacting with the database. We just let them log into the app, and then the app kind of handles everything from there. So first thing I'm going to do is expand the localhost server, go to security, logins, and I'm going to right-click the logins folder and make a new login. So this one, we'll just call it service account, and it's going to use SQL Server authentication, and we'll give it a generic password here, test1234 exclamation point. So that's going to be the password that this app uses to log in. Also, for purposes of making this demo easier, I'm going to uncheck enforce password policy. And when we are done here, we go ahead and move over to server roles. Go ahead and just give it sysadmin. Of course, in a real-world environment, you would probably be a lot more specific about the way this user authenticates and what rights it has over the server, but we're going to keep it simple today. Sysadmin lets them do everything. I don't think we need to give them any other settings. Sysadmin kind of takes care of all of that. All right, there we are. Of course, it's always a good idea before you get started to click File, Connect Object Explorer, and just make sure you can connect using SQL authentication as this new account you created. Service account, my password, and as you see here, I am able to connect. Wonderful. All right, so we don't really need to be logged in as that user to write anything, just as long as we know it can log in. So let's go ahead and just start writing the query. So I'll get all of this stuff out of the way, and I'll write the whole thing from scratch. So go ahead and right-click the server, click New Query. And first thing we're going to do is we're going to make a database where information about users can live. It's going to store their password, and we're going to talk about how we store that in a secure way so that if there's a data breach or whatever, we don't expose people's information. So first thing, we'll keep it simple. Create database testDB. All right, and that's done. So once that's done, you want to refresh your IntelliSense, which is the thing that sort of autofills queries as you're writing them. If you hold Control, Shift, and R, that's going to refresh IntelliSense. So Control, Shift, R. Now we can come down here and say use, and I start typing testdb and it autofills. That's why we refresh IntelliSense, so it knows that that exists. Hit tab to autofill it, run that command. Now you see here that the database context has changed, and any queries I start writing are going to be written within this database. So go ahead and get a table going. So if you're making a table for users, it's generally going to look something like this. I'll kind of write it out and then I'll explain when I'm done. We're going to start with a user ID. Give them a first name, last name. Give them an email address. Password. I'll explain why I'm using this data type in just a second. The same goes for the salt, what it is, why I'm using it. We'll get there. And then anything beyond that is, just down to what you're going to be doing with the database. Maybe throw in something like created on. When was the user created might be helpful. And this is obviously a very simple version of that table. So then, before I actually create the table, let's kind of talk about what I'm going to be doing with these fields. Just some good practices when you're making tables like this. So with the user, you see that it's an integer, which is going to be a whole number. So every time I create a user, they're going to have a unique identifier, and it's going to be auto-assigned using the identity property. And what this means is starting at ID 1001, incrementing by 1 each time. First name, last name, simple enough. Email, we might add some constraints here. Usually, if they're going to be using the email to log in especially, it's a good idea to add a unique constraint. So what this will do is prevent duplicate emails on inserts. So SQL Server will actually stop you from inserting new rows into this table if it detects that the email address that you're using is already there. Next is the password. The reason I'm storing it as a binary data type is because this is actually going to be a hashed and salted password. So more on that in a few minutes. Same for the salt. The salt is part of the salt hash. We'll explain more. And finally, for created on, there's a really cool constraint in SQL called default, which will basically tell it whenever you insert something, you could specify a date, but if you just leave it null or blank, then the system will automatically populate with something. And in this case, something is getDate, which is a really cool function that SQL Server has built in where you just run it and it'll say, all right, well, here's the current date and time. So on null insert, populate current server timestamp. That is important to note that that's server time, so I'm on US Central, but if this was UTC or something, that would be the time that goes in there. Okie doke. So I think that's all I'm going to do. We don't really need to talk about the rest of those features, like not null or anything like that. So the table is created. Don't forget to refresh IntelliSense again, just so it knows that now there's a new table in the database. I'm also going to comment this out so I don't accidentally try to run it again. So what we're going to do now is just look at that table. And we see that there it is. It's empty. So let's talk about inserting into this table. How do we create users? I won't really talk about creating stored procedures or anything. We'll just kind of manually make a user or two just to get us going. So typically an insert is going to look like this into this table. So we insert into the table, we specify which columns we're inserting because, like we talked about, some of the columns we actually don't need to worry about, like user ID, that's automatically assigned using identity. Created on has a default, so we can kind of skip those and just have the name, email, and password information put in. So we're going to be inserting a first name, a last name, taking advantage of IntelliSense here to autofill all of this stuff for me, email, password, and we're going to need the salt. So the way this works, I guess before we actually do the insert, we'll get that set up for me. Instead of inserting right away, I'm going to kind of talk about how the passwords work. So if I were creating a user, I'm going to insert their password a certain way. So declare password. I'm just going to make a variable here. And we'll use our same password that we've been using. and we'll select it, right? So if I declare and select the password in the same statement here, obviously storing passwords in plain text is a horrible idea. If you store passwords that way, which I've worked at places that do that before, you're really setting yourself up for a big problem. If somebody ever breaches the database and gets access to the table where this stuff lives, they now know, well, okay, these guys with these email addresses have these passwords, and the thing they're going to do is go try to log into other websites with those credentials, like maybe their bank, social media, whatever. So we have a responsibility as a DBA to make it as difficult as possible for that to happen. So the salt and hash, it's important to talk about when we hash and salt this password, we're not really preventing users from looking at this table and then figuring out how to log into our system with that information. If they have access to the database, we're already in big trouble as far as that's concerned. The thing we're trying to prevent here is decrypting or reverse engineering what the password is so they can go to other websites and log in. So that's the main goal. Kind of write that out here. Salt and hash is to prevent passwords from being decrypted for use in other systems. And that's really the goal here. So maybe what we do, instead of just having our password be this random string, or this plain text string, we're gonna hash it, it's called. And what's cool about hashing is SQL has some built-in hashing functions. So we could say hash bytes, and I'll kind of type it out and then I'll explain it. Alright, so what I'm doing here is I'm saying the password string is going to be hashed using SQL's hash bytes function, and the algorithm here is SHA-2 512. So if you read about it, SQL has a lot of hashing algorithms it supports. If you want to really go down the rabbit hole, SHA-2 is actually not considered very secure anymore. Realistically, if you're doing this in the real world, you're going to want to go outside of SQL and use some front-end method of hashing the password, because SQL's built-in methods, none of them are actually considered secure by today's standards, but this is considered good enough for demo purposes and just sort of understanding how the process works. So let's select it real quick. Great. So when I do that, the result is this, googled up string of characters. We could even try it as binary 64, which is the data type that we're going to be using. And then it's a little more readable, but it's still, obviously there's nothing in here that you can use to log in. Now there is sort of a problem built in with the hash alone. Now remember, we set up here salt and hash. I'm going to talk about why we do that together. Because the problem with the hash is, if I do this over and over again, you'll see that the hash is exactly the same every time. And the problem with the hash by itself is, if two different users have the same password, then they're going to have the same hash, which still doesn't really solve the problem. It still means it's something that can be reverse engineered. If I know that test1234 equals this hash, then I can figure that out in the database. So to complicate it a little bit more for any bad actors, we're going to throw in a salt. So the way that's going to work is, let's do a salt up here. Declare salt, and I'll write it out and then I'll explain it. Declare salt, unique identifier equals new ID. So this is another cool thing that SQL Server has built in, is the ability to generate a new, they call it a GUID, or a global unique identifier, on the fly, new ID. And what that is you see here, it's a completely random, completely unique string of numbers, letters with hyphens in the middle. And that'll never be repeated. It'll always be a new GUID every time. There's a lot of good reasons in SQL Server to use GUID, but for salting, that's definitely what you want to go with. And the reason is, we're going to take that salt, and instead of just hashing the password directly, I'm going to go ahead and say we're hashing the password, test1234, plus salt. And you can't really do salt directly, because if I try that, it's going to throw some sort of conversion error. Well, that too, but there we go. So it doesn't like that I'm using two different data types. So to make it a little easier, I'm going to convert this cast as nvarchar36. And now what that does is it generates a hash, but that hash is not just the password. That hash also includes a completely unique and random salt. And we see the end result here. If I look down at the bottom every time I run this, the new output is completely different every time. It'll never be repeated. Even if two users have the same password, they're going to have completely different password strings stored in the database. So that's a high-level look at the way we're going to be interacting with passwords, both storing them when users get created and also when users log in. We're going to have to figure out how do we know that the password the user typed matches whatever is in this string. So with all that in mind, let's go ahead and get a user inserted into the database using all of this stuff. So back up to my insert statement here. So we're inserting a first name, last name, email, password, and salt. So first name is easy enough. We'll create a Hank Hill for the last name. Email is hhill@arlen.com. And now for the password. So we pretty much figured out the password thing already, so we can kind of just steal it from here. So the password is going to be hash bytes using the SHA-512 algorithm. We got to replace this manually typed password with, well, normally we do a password variable, but we'll go ahead and say like that. And we have to declare the password up here. Equals, and again, we're using test1234. So now when we run it, it's going to put test1234 in here, as well as the salt, which I also need to grab. There we go. Okay. So if I have this thing written correctly, it's going to insert a row into my new users table with Hank Hill's name, email address, and this password, but it's going to be hashed and salted. Oh, I forgot the salt at the end. That's important. You want to make sure you're storing the salt in the database. Because it's part of that hashed string, we're going to need to retrieve the salt when they go to log in. So let's run it and then kind of see what that looks like. All right, so one row affected. Let's come down here and select on that table again. All right, and so that's what a good user table is usually going to look like. So we've got his ID, we've got some basic information, but the secret stuff like the password is salted and hashed. And if I were to create a second user with the same password, we know that it's going to be a different string because we're properly salting and hashing. So we'll do like Peggy Hill. Obviously, we can't use the same email address because we have a unique constraint which will prevent that. So we have to make sure it's a different address. And even though she's got the same password, if we look at that table again, we see that two different strings. So somebody looking at this table would not easily be able to tell whether or not they have the same password, and they certainly would not be able to kind of decrypt that and say, okay, well, these other passwords are also test1234. Okay, so the last thing we need to do before we start going to the front end and writing the code for an app that lets you log in as one of these users, we want to create a stored procedure for logging in. The idea is when a user logs in, they're going to type their email address and their password, and it's going to need to match that against this and figure out if it's the correct password or not. So we'll create it in the same statement here. Go ahead and comment out everything I've done so far just to be safe. And we're creating a stored procedure, and it's going to have two required inputs. The inputs are going to be email, varchar50, and password. Usually I go up to like 100. I think longer passwords are better. If you want to be the kind of guy who has a 100-character password, great. Okay. And this proc is going to be pretty basic. It's just going to... You can really be creative here about how you validate the login, but the way I want to do it is select the number of users that match the inputted email and password. And it's always going to be either a 1 or a 0, which a front-end app will have an easy time looking at that result and deciding if the login worked or not. So that's sort of my approach to it. So we just write the select statement. Select the count of users. Obviously, there's 2 users in here right now, but we're going to start adding conditions. So select the count from users where email equals the email variable. That's the first thing, obviously. If they type the wrong email address, it's not going to match. And password And we got to get a little creative here, right? Because we can't just do password equals password, because then we're not going to match up on anything. So we can pretty much just steal the hash bytes command we wrote last time, if I can find it. There we go. So we copy hash bytes, and if we read through that, right, so it almost works. The only problem is it's trying to grab this salt variable, which this is why I said it's important to make sure we're storing the salt in the database, because what it's going to do is, obviously we aren't going to ask the user to provide the salt on login. Once it finds a matching email address, it's going to grab the salt column. So by removing the @ sign there, we say it's not a variable, it's actually the salt column of the database. So select the amount of users who have the email address I typed, as well as the hashed and salted version of whatever I typed in the password. So let's get that created. And it's always a good idea to refresh IntelliSense again, Control-Shift-R. Now what we can do is we can run the procedure a couple times to see how it works. So USP login. If I highlight that and press Alt F1, it's going to show me some basic information about the procedure. Specifically, it's going to tell me down here that there's 2 input parameters I need to enter, the email and the password. So now I can run the login procedure. So for example, if I do Hank or Peggy Hill and I know what their passwords are, right, so when I run that, it returns 1, because 1 is the amount of users that match the information I typed in. So that's good. That indicates a login success. And so if I type passwords that are not correct, it's going to return 0. That's kind of going to be my invalid credentials. If I enter an invalid email address, it's going to do the same thing, right? So it validates both email and password. Oh, it's kind of a good idea you could get specific and tell them what was wrong. Was it the email or the password? But generally, you don't want to do that. You don't want to make it easy for impersonators to figure out, am I getting warm or is this close? So that's pretty much all that I need to do on the SQL backend. I've got a users table, which is what is going to authenticate the front end. And then I've got a stored procedure, which is a great way for front-end coding to easily run SQL commands. So with that in mind, let's start building a quick and dirty app that's going to let us log into this SQL Server as long as they have the right credentials. So the way that's going to work, let's go ahead and open Visual Studio and start a new project. If I do that a little slower in case I was too quick the first time, File, New Project. Give it a name, login app. It can be whatever. Oops, that's the... Sorry, we got to type in the type of app. We're creating a WinForms app. Now you want to be careful here because there are actually 2 types of WinForms apps you can use. There's .NET Core, .NET Framework. I don't really know enough to say the difference other than that .NET Core never works the way I want it to. So what we're doing today is going to be .NET Framework WinForms app. So let's go ahead and select that. Click Next. Give this an app here. We type in the name, login app. You can move it to a different repository location if you want. As far as the .NET framework, I just use 4.7.2, which is right now the latest version. And let's create it. Right. So if you're learning C#, WinForms is probably, in my opinion, the best way to learn because it's a good kind of C# for beginners type of thing where you have a graphical user interface you can design the app with. So you don't got to start directly out by just typing everything. And Visual Studio does a good job of letting you kind of drag and drop things into it and see the code change in real time. So it's a really good way to learn, in my opinion. So if we're building a WinForms app, it always kind of starts out with this one form here. In fact, if I press F5 on my keyboard or click the Start button here, it'll actually build and deploy the app. And even without entering a single line of code, I've already got a functional app here, right? It doesn't really do much. It's just a window that I can move around. But that's an app. That's all there is to it. So, before we really start getting into the heavy stuff, we'll just kind of talk about the basics, right? The order that I like to build apps in is get as much of the interface built first, and then go to the back end into the code and start making it actually do things. So if you expand this toolbox on your left, this is where all of the objects you can throw into this app live. And there's a ton of cool stuff here. WinForms are not new. They've been around since probably the 90s. I don't know. There's videos from like 2003 about this. So what we're going to do is we're going to start by adding text boxes. So if you start filtering down on the word text box, you'll see the control come up here. Go ahead and just drag and drop it anywhere into the window. Maybe expand it a bit. And this first text box is where my users are going to type their email. So while the text box is highlighted, make sure you select the Properties tab somewhere on the right-hand side of your app. Click the text box, go to the Properties, and the basic properties are all controlled here. All the things about what kind of text is allowed here. For example, you see a max length property, which says how much data can they put in there. Good things to think about when you're programming an app is always think about like how are the ways people can break it. For example, one thing we know is they're going to be logging in using this login procedure, which declares email as a 50-character input. So back in the app here, if they were to input 32,000 characters worth of data, that would actually break the procedure. So if you're really programming this for end users, you want to take care of things like that to make it as hard as possible for them to get errors. But we'll keep it simple today, and we won't really make all of those assumptions. So this text box, we'll make sure and just take care of, there's really two properties I care about. The big one is the name. So when you add objects into a C# app like this, it gives them generic names, which makes it kind of difficult to keep track of as the app grows. So it's a good idea to give them easy, simple names like email text box. That way I know later when I'm calling the email text box, I know exactly where that is, what it does. The second property would usually be like what is the text going to be, but we're not going to start it out. We're not going to pre-populate it. This is something they're going to type in. So we've got our email text box. Let's go ahead and just copy and paste that because we want another text box of the same size. And instead of calling it text box 1, we'll call this guy password text box. So this is where our password's going to go. And if we just launch the app, it's always a good idea. Every time you make changes, stop as often as possible and just kind of make sure you can build and deploy the app. That way, if you do anything wrong, if you get any errors, it'll be easy to know, like, well, this is the last thing I did before I had a problem. Right, and it's also good to identify problems like this, which is that as I'm typing my email and password, I notice that the password actually shows plain text, which never a good practice with passwords. So if we either close the form or if you go back to Visual Studio and click stop here, this will stop debugging the app and take me back here so I can keep working on it. Let's highlight that password text box, and there's a property down here called password care, and this is where I can specify, you can kind of read the comment down here that explains what this does, but it basically says, well, this is a password field, and whenever they type in some letters, instead of the letter, I'm going to show some character. Typically that would be the asterisk, although there's nothing stopping you from putting anything you want in there, like an X, right? So now when I start typing, it just shows X's instead of whatever I typed in. Either way, whatever you do is a good idea because then it recognizes that this is a password field, and it puts some other, it kind of automatically makes some other assumptions, like if you try to copy and paste out of the field, the app will actually stop you. So Visual Studio really handles a lot of the fine details like this on our behalf. Okay, so we've got our email, we've got our text box. Probably a couple other quality of life things you want to add in are labels. If you label your inputs, then it makes it easier for the user to understand what they're supposed to type in there. So same thing, make sure you name your labels just in case you need to do anything with them later. So call that our email. And then here's the second property. You can change the text because right now it says label 1. Make that say something like, put your email here. Copy and paste it. And this one is going to be our password label. Go ahead and change that guy to say password. Right. And it's a real nice kind of drag and drop interface. You don't have to write the code to like manually declare the position of all these objects. You can just move them around. And then, of course, the last thing, probably some sort of button, something they can click, after they've something they can click after they've, boy, what did I just do here? Made an event handler. We'll talk about that in a second. Something they can click to submit and attempt to log in. So it can be a link. C# or Visual Studio has link labels you can add in. But in this case, we'll just do a button. All right, so throw in a button. You don't got to be super fancy about how you line it up, but we'll drag it here. And same thing, we're going to change the name to login button, and the text, I don't know, something like that, login. All right. So once again, just kind of launch the app, and we see we got a pretty good login screen going here, right? So we can type in our email at AOL.com, type in your password, and then when you're done, you can click login. So without typing a line of code, you're able to build out a lot of stuff. Now, obviously, none of these, the button doesn't do anything, right? Nothing happens. This is where we have to start adding something called event handlers. You've probably heard of this if you've done any sort of programming or tech support before, where apps do a lot of event handlers, where when some event happens, we need to handle it by running some code. So we're going to add an event handler for the login button that says when they click this button, we're going to take this text that they've entered and run the SQL stored procedure here to try to log into the app. All right. So a couple ways to add event handlers. If you want to do it the old school way, if you have your form designer, this is called design mode, right? It says design here on the tab, and you press F7, that's going to take you into the code, and you can just manually declare an event handler here. So you can say, hope I'm putting it in the right place here. Login button click. So that's one way. If you do it manually like this, you do have to remember to do things like add the event handler. We'll come here. We'll kind of talk about what this code looks like in just a second. But if you manually add event handlers, you always have to remember to say login button dot click. I'll explain this when I'm done. But oh boy, there it is. Right. So the idea here is you have an event handler that does something when the button is clicked, but you have to tell the app to link that and say, when a login button click event is performed, the lightning bolt icon here kind of indicates that this is some sort of event, then you need to link at runtime login button click. So that's, like I said, that's sort of the old school way to do it. Visual Studio does have an easier way if you're interested, which is when you're in designer mode, you can actually just double click the object and it automatically inserts here. It says, okay, well, you clearly are trying to add some sort of event for when the login button is clicked, and it actually links the event handler. It doesn't do it here, it does it somewhere else, but the idea is code added here is automatically linked as an event handler. So it's easier to do it that way. It's whatever you want. Okay, so that's what we'll do. We'll add the event handler here. But before we do, let's just take a very quick moment to explain, like, what does this look like? Because this is kind of the shell of the code for a Windows form. So the first thing is, everything up here is code libraries that are loaded at runtime. So whenever you run a desktop app, it has to, like, Windows comes with a bunch of code library installed on them, and it has to load them from your local machine or sometimes from the app itself. And so it's loading all of these, like there's a forms code library. So that's going to come into play in just a minute. This section here, this thing that says form 1, everything in this section executes at runtime when the app starts. Or the form opens. What's important there is if you have things you need to happen immediately when the form opens, you can put them in this section where the initialized component lives. We'll do a real quick example of that, right? Like, so if I want a pop-up to display immediately when the app opens, the control for that is message box. The app is open. Right? Keep it simple there. And so the syntax there is we're creating an object called message box, and we're showing it with the text the app is open. Important to know, by the way, if you're doing C# for the first time, Unlike SQL Server, where the semicolon at the end of a query is optional, you absolutely have to put the semicolon at the end of your code, or else the app will not even build. It'll tell you here that a semicolon is expected, and the app won't even build. So it's not optional, it's mandatory in C#. Anyway, so let's see what it looks like when I have a message box show at runtime. Right, so you see here, before the form even displays, right away it's doing my pop-up that says the app is open, and then the rest of the business happens. So that's really useful. There's a lot of good reasons to have a lot of code run at runtime, but we'll go ahead and comment that out because that's not what we're trying to do. Instead, we're just trying to add a login button click event handler. So this is where we really have to kind of step back and talk about connecting an app to a SQL Server. That was one of the hardest things for me to learn when I was first learning to code was how do I make an app interact with a database? And the way we do that is with something called connection strings. And there's a lot of different ways to add connection strings to an app. The way I'm going to do it is not really super secure. There are ways to encrypt the connection strings so somebody doesn't download the app and look through the installation files and see what the system administrator's login is. We're not going to go into that. We're just going to keep it simple. So the one way we could do it that's pretty easy is before it even does the runtime, we can, right after the class is declared, form1, which is the name of the main form here, we can declare a SQL connection. We start typing SQL connection, and right away, before I'm even done writing the whole thing, we get the squiggly line and this little light bulb comes up. So this is what I like about Visual Studio is Visual Studio will tell you right away when something's wrong, and when it can, it's going to make suggestions. So it's able to surmise here that whatever I'm trying to do is probably use some SQL commands. So it's asking me here, using SQL client, it's saying, do you want to load the code library for SQL so you can start writing SQL commands? And I'm just going to click that. And what it did, if you look closely, is, here it is, it added the code library. That's why I talked about that earlier. It said, all right, well, we're going to load at runtime the SQL client library so that it can start running SQL connections, commands, whatever. That's good. So we're declaring a new object of SQL connection. We're going to name it, maybe call it con. And it's going to be a new SQL connection. And then in parentheses, we have to type information about it. So let's stop here and kind of talk about like what does a SQL connection look like? Well, the answer is I've been doing this for a long time and I'm still not very good at it. So what I always do is just go to Google and it autofills because that's exactly what I was looking at. SQL connection strings. There's just a website, connectionstrings.com, where it just shows you a bunch of different examples of SQL Server connection strings. And there's a lot of different types depending on how you're trying to connect and how you're trying to log in. There's really only one that I'm interested in, which is, if I look for one with an initial catalog, yeah, good enough. So this isn't the exact string I want, but it'll be easy enough to sort of form into what it needs to be. So you saw what I did here is I'm just putting the connection string directly in the form, which is one way to do it. It's not how I'm going to do it, but I'm going to get it started this way at least. So we'll kind of talk about what these elements mean. So the first thing it asks for is a data source. What the data source is the name of the server. Where is the SQL server that you're connecting? Easy for us because it's installed on my desktop, so I just use localhost, or if you really want to be lazy, the dot will work. We'll do localhost. This is to specify port 1333, which is the default port, so I don't really need that. Network library, not going to use that. These things are all separated by semicolons, so make sure you don't screw that up. Initial catalog, also optional, but what's cool about initial catalog is you can tell it to sort of use a certain database by default. And in this case, we are actually going to do that because if I look at my databases, I believe testDB is the one we were just using. I could have sworn, oh yeah, it's right here. Yep, so initial catalog is going to be testDB. And the last two elements here, the user ID and the password, this is what matters. And this is where you get into a bit of a security risk if you were to just dump it directly into the file like I'm doing now. So like I said, we did create that user. That was one of the first things we did. If we go to security logins, remember we created a service account, always a good idea. And make sure you when you're entering a connection string, it's always a good idea to just double check. Make sure you definitely know the service account's password and that you're able to connect using it, because that's what you've got to put in here. So user ID is service account, password is. And so like I said, there are ways to encrypt it. Don't really worry about it for now, but that's one way for us to just tell the app, okay, this is how we're connecting to SQL. Now that being said, one thing I will do, even in a demo, is I don't like punching it in directly here, because the big problem that gets created is when you build an app, you might end up with, 10, 20, 30, hundreds even of classes, depending on how big and crazy the app gets. And you don't want to be having to call this connection string like this every single time you have a new form going. So instead, what I'm going to do is I'm going to take this string and I'm going to copy it to my clipboard. And this is just one way somebody showed me that I really like. If you expand the Solution Explorer pane and go to program.cs. So this is one of the sort of main forms that an app uses, where a lot of kind of global stuff happens. And in here, I'm going to declare a special kind of string called a static public string. And what I've just done here is, this is a string that lives inside of program that has all that information. Like I said, it's not going to really stop somebody from figuring out where this program file is. But the big thing this offers is convenience, because now that I've added the connection string to program, if I go back to my code here, now I have a much easier way to pull the connection. So pull the SQL connection string from program.cs. Now what I can do is just start typing program.constring. So this is a really cool thing you can do, which is just pull data from another part of the app. And so obviously this is a much cleaner, much easier thing to look at. And again, not a whole lot of defense here, but if somebody's looking at the code on this form, they aren't going to be able to immediately say, okay, here's the password for this user. Okay, so that's the first step towards getting the connection string pulled into the app from program. Now we need to go ahead and focus on this event handler again. So remember, if you double click on the login button or if you manually create it, doesn't matter. And let's go ahead and start typing in what needs to happen when they click this button. So the first thing we're going to do is we're going to tell it that there's a SQL command we need it to run. So declare the stored procedure command, because that's the type of command we're running, right? You can directly do it if you want, but we're gonna go ahead and proceduralize it. It makes our lives a lot easier. So a thing we're gonna execute here called a SQL command. Give it a generic name like CMD. And what you type in here when you're declaring a new SQL command can really be anything. There's actually nothing stopping you from just writing SQL here. Like, that would be a perfectly valid type of command to run. And sometimes I do that if I'm feeling lazy or I have a very simple query to write. I won't bother making a procedure out of it. I'll just execute it directly in the app. In this case, though, I think the complexity of the login command makes it necessary to do this. So let's go ahead and grab the name of that procedure. The schema is not necessary if it's DBO. Otherwise, if you use some other schema, it is. So in quotation marks, we say USP login. And there's actually a second part to this, which is con. So what that is, I'm telling it to run a command called USP login using the connection string con, which is what we specified up here above, right after the partial class. Now, when you do it this way, because it's a stored procedure, there's a couple extra steps that you have to perform. Specifically, you have to say that this is not just any type of command, this is a stored procedure. And if you're curious, what you can do is if you start typing command type here, and you hit period, it'll kind of autofill with the different types of commands you can run. Most of the time, it's text or stored procedure. All right, so let's go ahead and autofill that. So now it understands, okay, this command I'm going to run, it's a stored procedure. Next thing we got to do, of course, is remember from earlier when I was looking at the stored procedure, there's two required parameters. There's an email and a password. So you have to tell the app that it's going to be supplying that information from somewhere. So the way you start doing that is command.parameters.addWithValue, and we tell it what the name of the parameter is in quotation marks, which I believe it's email and password. Yep. So email. And what we do here is we're going to be pulling the values from the text boxes. You can do that, or you can actually just directly type it in. It kind of depends on what the procedure is supposed to do, but you know, tom@aol.com, that's a perfectly valid thing to supply, is just directly type it in. You can do the same thing with the password. Add with value. And, you know, you can say, password one, so that's certainly one approach to it. Obviously, we're not doing it that way. We don't want to really hard code in the information like that. As a matter of fact, what we could do, I'll show you kind of a quick, we'll add a second, like a test button here just to show off how pulling data from the text inputs is going to work. So if we make a button here just called test button, that's the text. The name is going to be text button. There we go. Okay, so we can do this real quick where let's make a quick event handler by double-clicking on test button, that when I click this button, it's just going to pop up and tell me what's in the text boxes. So that'll give you a good idea how event handlers can sort of interact with what people are typing into the form. So when they click the test button, we'll just do a quick and dirty message box.show. And your email is, and then we can concatenate things to the message. So we break out of the quotes for a second and we say plus, and we start typing the name of the text box, which is email text box dot text. So this says your email is, and then whatever is in the text box, that's going to get added to the string. And then we'll keep adding stuff. So we'll add a period here and we'll say your password is, and we'll do the same thing with the password. Right. So when I click the button, it's going to pop up and it's just going to tell me what I typed in. And that'll give us an understanding of how this data can be passed around the app to other parts. So tom@aol.com. And when I click the test button here, there it is. So it gives me a pop-up that just tells me. So that's how we're able to pass these parameters to the stored procedures. We're going to do pretty much the exact same thing. So let's close the app to stop debugging and go back to the login button event handler by double clicking it. And we just need to fix this here, right? Because we're not hard coding the data in, so we're going to get rid of what we typed into the second part of the add with value, get rid of the quotation marks, and we're just going to type in the same thing we did earlier, so email textbox.text. Do the same thing with the password. Password textbox.text. Right, so this is not done yet. We still got a lot more work to do, but we've set it up. So we have declared the stored procedure command. We've told it that it's a stored procedure. We've added the parameters. There's a couple things left to do. When it's time to actually run the command, you have to open and close the SQL connection. C# or WinForms especially, it enforces that. And it's always a good idea to make sure that you're not just opening connections and leaving them open. So we do a connection, con is the name of our connection string, so con.open, con.close, and then in between the open and close tags is where we're going to write the code that actually executes the command. The reason maintaining your connections like this is important and making sure you don't leave them hanging open is because a lot of times, if we go back to SQL Server for a second, a lot of times in a production environment, if we look at the connections server property, there's actually an option you can specify here that limits how many concurrent active connections there can be. It's a good way of making sure people don't bog the server down, but it does present sort of an issue where, you know, if I have 100 connections maximum and a lot of people are using this app, if I'm leaving connections open, I'm gonna run out of connections and I'm gonna start getting errors. So it's just something to think about whenever you're writing queries, is make sure you're closing the connection as soon as you don't need it anymore. Okay, so with that set up, we're going to go ahead and do the part of the code that runs the stored procedure, right? And just think about for a second what this thing is doing, right? When we run the stored procedure down here, it just returns a 1 or a 0. A very simple procedure. And that 1 or 0 is what we need to pass to the app. So we need to run the procedure in C# in a way that says I'm expecting a 1 or a 0, a whole number to come back. So what I'm going to do is I'm going to declare an integer. So int, we'll call it login result. And so it says, all right, well, this is an integer, and it's going to be called login result, and it's going to equal. And we're just going to populate it right away by running the command. So cmd.execute. And before I finish the command, you'll see there's a lot of different ways to execute a query. And they're all important for their own reasons. I won't go into all of them, but for example, you've got a non-query way to execute a command. That would be if you're just running some sort of command that doesn't return anything. You just need it to run so you can move on to something else. So that's certainly one way to do it. You've got an execute reader option, which would be if you're expecting multiple columns of result, like first name and last name in separate columns, a reader would let you kind of parse through those columns one at a time. Another way, though, which is the way I'm going to be using, is execute scalar. So the word scalar in code, if you're not familiar, generally means we're expecting one thing to come back, one single result. In fact, if you highlight execute scalar and read the note here, it actually says we don't really care what it returns. We're going to look at the first row, first column, and that's going to be the result that you get back, which is fine because that's exactly what this does. It returns a scalar result of 1 or 0. So execute scalar. Put the parents. We don't need to put anything in there. It just needs to run. And it's throwing the red squiggle, and there's a reason for that, which is if we hover over it, it might tell us here, yeah, there's kind of a conversion error. It says we don't really understand how to convert object to int. Basically what this is telling us is that when the app runs a SQL query, it doesn't really understand whether the result it's getting back is a string, an integer, a decimal. So you've got to be explicit and say, whatever I'm getting back, I would need it to be an integer. And the way you do integer conversion is with convert dot to int32, and then you put it in parentheses like this. So it's just going to attempt to convert. Whatever I get back, I'm going to try to convert it to an int32 value, which will match the variable type I'm trying to store the result into. Easy peasy. Okay. So we've got almost all of it done. There's only a couple things left to do, which is we've declared the procedure. We're going to... It's always a good idea to leave lots of comments on your code, by the way. So we're going to open the connection, run the command, store the result into an int so we can evaluate it afterward. So that's kind of the goal here. Once we run this command, we're going to have login result populated as either the 1 or the 0 from the procedure, and then we can look at it and make a decision. And we can keep doing that in the event handler, right? This whole thing needs to happen at the time that we click the button. So after we close the connection, let's come down. And there's a lot of things we could do, right? Like at the beginning of the video, we saw that in my app that I first had going, when the login is successful, it actually opens another form where I can, run some other things against the database, like selecting users. In this case, because we're just trying to explain how this whole thing works, we're going to keep it simple and just display a message for success or failure. So we're just going to tell them if it worked or not. We're not really going to get fancy with it. And easiest way to do that is we use if logic, if else, right? That's the easiest possible way to evaluate something. If this, then that. And in parentheses, we're going to say login result equal to 1. This is another small difference between C# and SQL, by the way, is that notice when I use the single equal sign here, it's because I'm setting the variable on the left side of it to something on the right side. However, when I'm evaluating, when I'm looking to see if something is true or false, I'm using double equals to say if the login result is equal to 1. In fact, if I were to only do one equal sign, it actually kind of freaks out. It says, looks like you're trying to do an if evaluation, which isn't the right way to do it. So 2 equal signs. That also is where you see sometimes, like if you're trying to do the opposite and say if the result is not equal to 1, you would do like exclamation point. And then, of course, the other arithmetic operators work here as well. If it's less than, if it's greater than or equal to. But with equal, that's where the difference is. You're always doing two equal signs if you're saying something is equal to something else. Okay, so if the login result is equal to 1, then we're going to display our success message. So login successful. That's going to be our success message. Otherwise, so the else is basically says, well, if whatever happened here is not true, then it's going to move down to here. And we're going to tell it invalid credentials. Right? Pretty standard type of error to get here. And I think that's everything. Let's try to build it. Let's see if it works. Hit F5, and it launches. Okay, so we'll try to log in now. We'll do a successful login. We'll do a bad login. We'll see how it works. So hhill@arlen.com, test 1 2 3 4 exclamation point, and it ran the procedure. It got the result back, and it gave us the message that the login was successful. And of course, if I malform my password, type in some gibberish, now we know it's not working. Invalid credentials. Successful. Same thing with it validates the email, right? If nobody with this email address exists, then it's going to throw the same error. And that's it. That's how you write a stored procedure to validate salted and hashed passwords securely. And that's how you write a front-end app that actually forces people to log in before they can go do other stuff.